Hello, everybody. As you can hear, my voice already sort of drifts away after one first day at HMI. So let's see that I can pull you through this topic of electrical systems and how that plays a part in accelerating our way towards sustainability. I'm Robert Andres. I am part of the executive team at Eurotech, and one of my responsibilities is strategic partners, and that gets me very close to AWS. So that's the reason why you see me here today. Eurotech as a company, and by the way, we have a booth here with us, is a company that takes care about all the complexities of the edge. So we are a company that integrates high-value assets of all kinds into infrastructures that require a proper IoT approach to it. And that ranges from locomotives to chillers, to air conditions, to what is another big thing? Industrial printers, for example, right? Or manufacturing floors. Where we play as part of this three-company thing that we are looking at here today is we really are at the edge. So we come from the OT side. We have been developing for more than 30 years edge computing systems that are distributed in applications. So starting from there, we do gateways, we do edge servers, we do edge AI solutions. But not only from a hardware perspective, we put an application framework on top that is our magic sauce that allows a very easy use of edge AI and acceleration technology in the end systems for edge AI applications. So from a vertical perspective, you see our core verticals here. That is industrial manufacturing automation, that is transportation, is energy, and we do quite a bit in medical. On top, as part of the engagement with AWS, we have an IoT platform that merely takes care about device management features, advanced logging capabilities, and features that you typically get in excess of what you get from an IoT core or Greengrass connection. We do seamlessly integrate with AWS Greengrass and with IoT core, as I will show going forward. But again, this story is around electrification. And we see so many systems that are part of our daily life where electrification components are essential. And if that is solar fields, and we do quite a few of these projects, whether that is any other highly automated, like this is in an oil field, oil platform, you have tons of electrification equipment. But also building management aspects. Electrification is a big part of it, not just in the data center, but also for the whole building management system, and then renewable energy aspects to it. So that's what we're going to look at here. And then, of course, EV charging becomes more and more an issue for the companies out there to integrate that from an energy management perspective as well. So now to the part that is the ABB piece here. So all of these components have to be integrated. And we always don't see what happens on the electrification side, right? It's those kind of maintenance rooms where the logic and intelligence for the energy management is. So this is an example of an infrastructure that builds up certain users, consumers of energy and energy productions. So think about, it is not just the electrical systems to come to an IoT solution that gives you the economic benefits. There is an IoT layer that allows you to get the data out of the field into the cloud and get it to have the applications accessing that data best close to real time to take the business decisions that you want to take. And that requires also on the highest level working with proper data models and AI to get the quick responses that you expect. So, a couple of pieces that come together. There is all that equipment that needs to be integrated. Now, since the speech here is about integrating ABB electrification components, that's one thing we do in a very nice way. But the solution we present here allows to add also all other kinds of elements that you have on the energy side to be included. The ABB integration just goes a bit further and makes it even easier. And then data models, that's typically what you apply on the cloud side of things, and the connectivity elements that are there. Security, by the way, cannot be an afterthought here. Security has to be something that is looked at from the very beginning and has to be designed in from the beginning. And we are very close with the general principle that also AWS teaches in that space. So let's look a bit more at the solution on a high level from a product perspective, and then go through the actual real-life example that we have here. So in this particular case, the hardware that is needed to monitor a set of these kind of electrification components can be rather small. So that's a quad-core ARM-based gateway with the application stack on it, and I'm going to show that in a minute. And of course, it has to be hardened enough to sustain the same kind of environmental conditions that you have on the electrification component side. And then on top of that, well, not on top of that, there you connect the individual assets. And you see here different kind of devices from the ABB electrification portfolio. On top of that, an operating system that is optimized for that hardware platform, as well as all the security management capabilities that you have to have there. Next layer is the application framework that I was talking about. And that application framework starts with the right field bus protocols already readily integrated. And let's go this. Then there is a no-code environment that allows very simply to connect the asset that in the best case is already predefined and connected to the cloud. And then you need, of course, the native connectivity into AWS. And we provide that in this setup for IoT Core, and we provide it also for AWS Greengrass, where we have a tight integration from our framework side. And then for device management, as I said, EC in the customer's account or as a managed services to complete this. So if you go now into a real example, and that is actually the ABB building in Milan, where they have put all these kind of assets that they have from an electrification side into that environment. So what are they doing with it? So first of all, renewable energy. They put solar panels on the roofs of the buildings, and that's an important aspect that needs to be monitored, right? You track the utility power consumption and how much comes in. Then you calculate CO2 emission impacts. That's another part of the exercise. You have e-mobility. So of course, all at certain times of the day, and you need to know when, this infrastructure to charge electric vehicles becomes a real pain and a stress to the overall system. And then at the end, you want to be able to really benchmark what you're doing against others and see how good you're doing from a sustainability perspective. So from an implementation side, this is what the graph looks like, and you see things like test labs, you see HVACs, that's always a big element, right, on the power bill. And you see EV chargers and solar on the roof. Now, for each of these, there is a device that does its purpose from an electrification perspective. Now, these devices now get connected to a gateway, and the gateway connected to AWS here. So that sounds all very easy, right? But in order to implement that and to deploy this, you need a couple of things. I do this quick. That's easy to find. That's the hardware that has been chosen for that kind of application. As I said, it's an ARM gateway, so it's not something very expensive, but with all the certifications that ensure the customer understands from a security perspective, from an integration perspective, that's a plain device. So, and that's just to complete the picture connectivity elements that are there, from GPIO to Ethernet to all the cellular connections and so on and so forth. So, but the really interesting stuff comes here. This is just the standard set of protocols that we provide for energy applications. It's steadily growing, and in energy, you get new protocols all the time. And you find a couple of old ones that are very odd. So we try to do our best with a standard offering that we then complement by helping customers that have very weird stuff out there to get that also integrated in the same way. So this is ready out of the box available. And the whole edge solution is really about getting this together with a no-code programming environment where on one side the asset in the field, on the other side the AWS connector you choose is basically already an application with a timer in between that says, of that device, with that profile, these data points have to be collected every 10 seconds and pushed into AWS IoT Core or Greengrass or whatever. So that's what we do here, and all of this being certified under 62443 4-2. So different integrations that are possible. The typical one with Core, very easy. We have the SDK integrated in the application framework, and then we have a way to integrate through to get all the telemetry data properly into Greengrass to move it up into the cloud. This just as one little thing to show you, you can actually do very sophisticated kind of programming things. We have now seen customers, this was always meant to be something easy for something fast and quick to do. And then there's all the programmatic integrations possible. But we've seen now even companies using it for integrating locomotives. And if you've ever been in that space, an MVB bus from a locomotive gives you between 5,500 and 6,500 data points. So your goal there is mainly to reduce the data points that you send up in the cloud and compute that, and use a lot of compute power to do this in your edge systems. But they program that kind of stuff in wires, in that no-code programming environment. That's a bit more boring, but that's the management level to it. And that gives you a bit of a reference architecture on AWS, how this is done. And again, the architecture is open, allowing you also to integrate other devices. So that just gives you a little bit of output, right? That doesn't have to be the end. It's a simple visualization, but it gives you an idea here on that side of where energy comes in and goes out, how much of that is green versus comes from an energy production that is either nuclear or whatever. So how am I doing with time? I hope I'm good in time. So one of the outcomes of this, and what I failed to explain, the architecture allows the assets to be predefined. So that somebody that programs a specific edge can select, actually in a drag and drop fashion, the specific asset and get all the asset definitions already into the no-code programming. So it becomes really a minute thing to connect that asset to the cloud. So this is also why ABB clearly states the time for implementing these things and installing them got down dramatically. And then it's ready-made, so the whole system is readily available with all the software stack, the no-code programming, the security certifications. The focus is really on the value that you create on the application side in the cloud. And then this just to say thank you. These are the 3 companies that have contributed to this. And please see us in the booth here at AWS. Thank you.